Okay, today's lesson we're going to be working on section 1.2 in our textbook, the method of substitution. Does anybody know what the method of substitution is already? Have you guys worked with it in grade 9? Yeah. Not at all? No? Yeah, Andy? Sorry? You did? You did it in grade 9. Okay, so basically, yesterday we talked a little bit about intersection point between two lines. Okay, there's another way of expressing that, and they call it solving equations. So intersection point of two lines, or finding the solution for two equations, is the same thing. Okay, the solution is the point where both those equations meet. Okay, so yesterday we graphed two lines, and then I predicted where those lines are. We could see where they cross. What was one of the problems with that method? I actually made a mistake there yesterday, right? Using that method. Steven?
Your graph could be inaccurate.
Yeah, your graph could be inaccurate, okay? And especially if you're graphing on the board, you don't have graphing paper. Another problem is not so much that it's inaccurate, but the lines themselves. Luigi?
I think it might be also because the numbers that you use at the bottom will determine the shape, like how the line looks.
The numbers you use at the bottom determine the way the lines
So
look?
like if the numbers are like larger at the bottom, the line will look different.
Not necessarily. The line should be the same. The line is the line. Once it's graphed, it should be the same. The problem is if they don't meet at a nice round number, right? So in that example yesterday, I said they met at 1, 2, but what if the lines crossed at like 1.865, 3.792, right? How are you going to figure that out on a graph? Which is possible, right? Depending on the slopes and where they intersect, it wouldn't happen necessarily at an exact point. Okay, so that's one of the major problems with graphing to find the solution, is just the accuracy. Okay, not only of your graph that you've created, but also where the points cross. They might not cross at a nice even round number. Okay, so that's a problem. Any other problems with that method? What do I have to do at the beginning? Yeah.
It takes a while.
It takes a while, good. It takes a little longer to draw it out. Also, I had to rearrange the equation initially, which is a lot of work. Arguably, yes and no. You can make a mistake just doing that before you even try and graph it. Okay, so there's a lot of kind of susceptibility to error with that particular method. Okay, this one I prefer much more. It's called the method of substitution. Okay, we're basically rearranging one of the equations to isolate one of the variables. Okay, and once we've done that, then we take that variable and we substitute it into the other equation. Okay, so the definition is solving a linear system by substituting from one variable from one equation into the other equation. The only thing I would add to that is you do need to rearrange the original equation in order to have that one variable isolated. Okay, so I'm going to show you a couple examples here. Okay, so the question says the lines y equals minus x plus 8 and x minus y equals 4 intersect at right angles. Find the coordinates of the point of intersection. First of all, does it matter to me that they intersect at right angles? Connor, what do you think? You think that's important to know? Sounds important. Definitely sounds important. But does it really matter, Matthew?
No, it doesn't, because it could be at a right angle either positively or negatively, so you can't tell.
Yeah, but not only that, but I don't really care about the right angle, right? And they're asking me to solve this equation, so they're asking me for the intersection of point. It doesn't matter if it's a right angle, okay? They haven't asked me what's the angle at which they intersect. They've asked me to solve this equation. When you say solve the equation, they're asking for the point at which these two lines intersect. Okay, so if I'm looking for the point where they intersect, I don't need to know what the angle is. That comes later. Okay, we're going to learn about that stuff a little later when we talk about right bisectors and other things. But for our purpose today, we just want to know where they intersect. Okay, so the first thing we want to do is isolate one of these equations for one of the variables. Okay, the nice thing that you can see already is it's already done. We already have the first equation isolated for y. Okay, it might be because it's the first example, so we're starting out easy. But you can see y is already equal to negative x plus 8. So all I'm going to do is take that value of y and sub it in for y in the second equation. Okay, so it's a good habit to getting into labeling the equations as we get into elimination in section 1.3. You're going to see that this is a good habit to have. Okay, so this is equation 1, equation 2. We're going to take the value of y in equation 1 and sub it into 2. So x minus...
Excuse me, good morning.
Hi.
Could we have 6 volunteers to come and pick up a desk each?
Sure.
Thank you.
Okay, so we can see now I've taken that value of y, I've kept the negative on the outside of the bracket, and I've substituted everything that was equal to y inside brackets. It's very important that you use brackets when you substitute in. Okay, because for a case just like this, where we have a negative sign in front of that y value, we need to make sure that that negative sign gets distributed to each term in the brackets. That's why you need to substitute with brackets. Okay, once I've done that, now I'm just going to multiply, rearrange, and solve for the one variable. So we have x plus x minus 8 equals 4. We have 2x equals 4 plus 8. 2x is equal to 12. X is equal to 6. Okay, once I have the value of x is equal to 6, I can substitute it into either equation to find y. So it's my choice. I could choose this equation, but because this one is already set up to find y, I'm going to choose to substitute into this equation. So y is equal to negative 6 plus 8. Y is equal to 2. Any questions there? That's substitution in a nutshell. There's not too much to it. The only trick is to first rearrange one of the equations in terms of one of the variables, and then take that variable and substitute into the other. We'll do a couple more. Okay, here are my two equations, 1 and 2. So I get to choose now not only which variable I want to substitute, but which equation I want to use. Okay, well, let's use x this time. So I'm going to solve for x in the first equation. I'm going to say x is equal to 5 minus y. Okay, I've just moved that y over. Now I have this, I'm going to substitute it into equation number 2. So wherever I see an x, I'm going to substitute this value. So 3, 5 minus y is equal to 7. Go ahead and multiply this out. We have 15 minus 3y minus y equals 7 minus 4y is equal to 7 minus 15 is minus 8. Y is equal to 2. Any questions there? Any questions with the math? Okay, so now I have y equals 2. Where do you want these? Wherever they fit. So I have y equals 2. I can substitute this into either equation. I'm going to choose the first equation. All right, let's just pause this.